That means it is not that metabolism of carbohydrate, protein, fat, these are separate. These are taking separately. No, they have relation with them, close relation, and this relation is suppose metabolism of carbohydrate. When carbohydrate is not available, body depends for energy on mobilization of fat, and this fat oxidation of fat provides energy. Okay, suppose carbohydrate and fat both are uh, deficient, both are not available. In that case, the proteins are used for energy purposes. Though protein, we have mentioned that carbohydrate, fat spare proteins, and in times of necessity, proteins can be proteins can be utilized for energy purposes. Suppose this may happen in starvation. In starvation, when fasting is prolonged, that is called starvation. Is it clear? So the metabolism and this integration of metabolism for integration of metabolism, liver is the unique organ. And liver is the unique organ. This liver is also responsible for maintenance of the blood glucose level. Is it clear? Then balance of many substances, many biomolecules is maintained by the optimal normal function of the liver. Is it clear? So integration of the metabolism, liver is the most important organ, and this integration, purpose of this integration of the metabolism is smooth functioning of the body. We want our body to function very smoothly, very uniquely, and in that case, integration of the metabolism with participation of organ, mainly liver. This is a system that is happening in our body. It is that is existent in our body, though we don't understand. But if we analyze systematically, we will be finding that this is integration. And you will be finding in lipid coat there is a picture where metabolism of carbohydrate, protein, fat, all have been shown together in a single figure. Okay, and with the help of that figure, you try to understand what I have said, and I will be stopping on these topics and starting new topics soon. And suppose in times of excess of a biomolecule, excess of glucose, and that glucose is stored in liver and muscles for future use as glycogen. Is it clear? Fat is also stored in the same way in adipose tissue. Fatty acid is stored in adipose tissues when there is excess of acetyl CoA. Okay, and there is unfortunately or fortunately there is no storage of protein. Proteins are not stored in the body, and protein should be taken regularly, and daily intake of protein, we know 1 gram per kg body weight. It is more in adults, it is not more in adolescents, children, during pregnancy, lactation, during healing from chronic diseases. So let us start. The students, I think participant number is 52. I think there could be entrance of 1 or 2 more students, 2 or more, 2 to 10 students, not more than this. Let us start body fluid renal system. We mentioned in our message. In renal system, there is some basic you have to overcome. You must understand basic. First, start with functions of the kidney. It is better to start with functions of the kidney. Function of the kidney is formation of urine. Formation of urine, excretion of metabolic waste products and toxic substances. These toxic substances could be produced within the body or it could be taken in our diet. In diet, suppose if we take the vegetables, fruits, they are for preservation. The preservatives are used, and these preservatives are potentially toxic for the body, and ঠিক আছে, toxic substances are to be eliminated through kidneys. Through kidneys. আচ্ছা আমি 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 দিদি বলি এটা এখানে রাখো। Is it clear? চলো ঠিক আছে। Okay. Besides formation of urine, with urine, this metabolic waste and toxic substances as their water soluble, they are passed in urine. Maintenance of the water electrolyte balance. Water and electrolytes which which we take in our diet. So these are maintained at appropriate level for the body by the kidney. By the kidney, excess water is eliminated. If the water is less, body shifts in intracellular from intracellular compartment. Water from intracellular compartment to extracellular compartment, maintaining the normal volume of the ACF volume. Electrolytes the same. Electrolytes, if excess, if sodium, potassium excess, that is passed in urine, and if it is less, these electrolytes are conserved. Okay. Regulation of blood pressure. Kidney also maintains it is responsible for maintenance of regulation of blood pressure. It is responsible for maintenance long-term maintenance of blood pressure. Other regulators are baroreceptors. Is it clear? And then it is also responsible for maintenance of the acid-base balance. This is most important. Acid-base balance. If in the body more acids are produced in the body, these acids are eliminated through kidneys. Acid and base which are excess, they are eliminated through the kidneys. So this is an important function of the kidney. Besides this, kidney performs endocrine functions. This is very important. Though it is not a conventional gland, still it is performing an important endocrine functions. It is also performing metabolic functions. Metabolic functions mostly performed by the liver, but kidney has also significant participation, though not like as liver. Okay. So this is in short the functions of the kidneys which you are to endocrine. First comes from interesting thing, the endocrine functions of the kidney. Kidney performs most important hormone erythropoietin. This erythropoietin is responsible for maturation of red cells, maturation of erythrocytes. Is it clear? Calcitriol. This calcitriol, this is the active form of calcium. It is calcitriol. The active form is produced in the liver. By enzyme 1-alpha hydroxylase. Another uh, uh, enzyme or hormone. This renin can be designated as enzyme as also as hormone. This renin is produced by the juxtaglomerular apparatus. This renin is play a very important role in maintenance of blood pressure and maintenance. So these are the biomolecules, important biomolecules synthesized by the kidneys. Is it clear? Liver produces a number of more biomolecules, but kidney is also producing some important biomolecules, and most important is the erythropoietin. This is also a site of action of important hormones. Some hormones which are produced in other places, carried by in body fluid, uh, are acting on the kidneys, are acting on the tubules of the kidneys. One such important hormone is aldosterone. This is a mineralocorticoid produced in the adrenal cortex, suprarenal cortex. Is it clear? This aldosterone, which is responsible for the maintenance of electrolyte balance, it acts in collecting duct and late distal tubule. In collecting duct, what is its function? Absorption of sodium in exchange for potassium excretion. This is the function of aldosterone. Antidiuretic hormone. This is secreted from the hypothalamus, stored in the posterior pituitary. This is secreted, and this is very important for maintaining water, maintenance of the water balance. It also acts on the collecting duct, late distal tubule. Is it clear? And the ADH, antidiuretic hormone. Is it clear? This is responsible for absorption, reabsorption of water. If there is no ADH, that means if there is no ADH, it means urine will be dilute. Okay? If there is ADH secretion is more, that means urine will be concentrated. Is it clear? Urine will be concentrated, ADH. Okay? And so ADH secretion is almost nil when there is the dilute urine. It is secretion is more when the body is in need of more water, and ADH conserves the water. It is absorption occurs through the kidney tubules. Is it clear? Parathormone. This parathormone, which acts on proximal convoluted tubule, is responsible for maintenance of the calcium balance. Anti-natriuretic, actual natriuretic peptide, it acts on the distal tubule. Its function is when the sodium is more, it causes natriuresis. That means elimination of sodiums. And if sodium is more, extracellular fluid volume will be more, and there will be atrium will be dilated, and then this will cause release of atrial natriuretic peptide, and it will be carried by blood to the kidneys in the distal tubule. It acts by responding natriuresis. That means removing, that means eliminating more sodium, and that causes the sodium. That means sodium in the sodium concentration in the extracellular fluid to normal. Okay. Prostaglandins. In kidney, there is some important prostaglandins are produced. Notable is PGE2. It regulates. It is important in the regulation of the renal circulation. That means regulation of blood flow through the kidneys. PGE2. This is the site of action of some hormones. Some hormones are also inactivated in the kidney. These are number is few. Insulin, glucagon. 60% of the insulin is inactivated in the liver. Rest 40% is inactivated in the kidneys after its action. When action of insulin is over, is it clear? When its action is over, it needs to be removed from the body, and then this removal is by inactivation. Is in a most important site is liver, 60% in normal health. Is it clear? And rest 40% eliminated in the kidneys. Is it clear? In diabetes, the ratio, the changes 60%, 40% eliminated, 40% inactivated in the liver, and 60% in the kidneys. Is it clear? So these are the hormones that are inactivated and excreted in the kidneys. Insulin, glucagon. Next, this is the endocrine function, metabolic function. We know the gluconeogenesis takes place in the liver. Okay, it is taking place in the mostly in the liver, and some gluconeogenesis takes place in the kidneys. Is it clear? Not only this, some amino acids are also degraded in the kidneys, and it is another important function, metabolic function, is maintenance of the calcium balance. So these are the metabolic functions that is maintained by the kidney. Okay. Next. Okay. Now our main topics is peculiarities of renal circulation. Peculiarity, this word we use, that it has some dissimilarities with the ordinary circulation. And this dissimilarity is designated as peculiarities. You see, the first part is kidneys are highly vascular organ. In bodies, there are some highly vascular organs, as for example, adrenal gland, the kidneys, is it clear? Kidneys. Then spleen. These are the also liver. These are the liver, heart. These are the organs that are highly vascular. And kidneys is one of the highly vascular organ, and it can regulate. Kidney can regulate its own blood flow within the range of 80 to 180 millimeter mercury. Is it clear? It can regulate its own blood flow within the range of 80 to 180 millimeter mercury. If the range is more or less, then kidney's participation becomes less. And renal blood flow can also be influenced by sympathetic nerves and hormones also. Is it clear? Like portal circulation, this regulation, auto-regulation, suppose kidney blood pressure, a person's blood pressure is 120. From 120, it has decreased to 90. In that case, kidney will be operating to bring the person's blood pressure to normal. Again, when the blood pressure is say 170, like this 170, 160, in that case, this pressure is high, it should be lowered. That function is also performed by the kidneys. Okay. Portal circulation, it has some similarities of portal circulation. And a portal circulation is has two sets of capillaries, and this nephrons, the structural unit of kidney is nephrons. This nephrons has two sets of capillaries, glomerular and peritubular capillaries. Glomerular capillaries, duct of 50 capillaries, and peritubular capillaries. Peritubular, that means these capillaries surround the tubules of the kidneys. Okay, tubules of the kidneys. And these glomerular and peritubular capillaries are connected by efferent arterioles. Okay, segments of distal convoluted tubule and nephron, where the distal distal convoluted tubule, you can imagine from our this is review class. So I don't think that pictures should be shown anew, but if difficulties occurred, it can be shown. The ascending to the uh, from the glomerulus, Bowman's capsule to proximal tubule. Proximal convoluted tubule has two portions, straight convoluted portion, straight portion, then loop of Henle. Loop of Henle is two portions, that descending limb, ascending limb, and this ascending limb ultimately leads to convoluted portion of the distal tubule. Is it clear? And ultimately, it leads to distal connecting tubule, and distal connecting tubule leads to collecting duct. This is the that means this is the system. This is the regularities through which it is arranged. It is clear? Is it clear? And segment distal convoluted tubule have intimate contact with afferent arteriole. This afferent arteriole and this convoluted portions, as they are convoluted, so they are loose, and they have at one point convoluted tubule comes very close to afferent arteriole, and from that portion, the portion of point of contact is called juxtaglomerular apparatus. Juxtaglomerular apparatus. Or juxtaglomerular apparatus, function of the juxtaglomerular apparatus, secretion of renin. It regulates the renal blood flow and also electrolyte. Okay. Low oxygen in comparison to heart, its oxygen extraction is very less. Is it clear? That means with less oxygen it can work. With less oxygen, that's why it acts in shock. When a person is in shock, at that time the kidneys can also work because oxygen consumption is less. In shock, there is less blood supply to organs, and that means less oxygen supply to organs. Glomerular capillaries are high pressure vascular bed. In ordinary capillaries, the capillary hydrostatic pressure is 30 to 32 millimeter mercury. Ordinary capillaries, capillaries of the muscles, capillaries of skeletal muscles. Is it clear? Or other capillaries in other tissues. Okay. The percentage is being given. Don't worry about percentage. But here we see the hydrostatic pressure, capillary hydrostatic pressure is 60, almost double the pressure of the ordinary capillaries. Is it clear? And this high pressure is because of filtration. Within this high capillary pressure is because it helps filtration of plasma. And peritubular capillaries, we have, as we have already mentioned, this is a low pressure area where pressure you see only 13 millimeter of mercury, much below the ordinary capillaries, and it is concerned with the reabsorption of the glomerular filtrate. Glomerular capillary, another important peculiarity is glomerular capillaries are 50 times more permeable than ordinary capillaries. And this also helps in filtration. Glomerular capillaries are 50 times more, on average, 50 times more permeable than ordinary capillaries. Okay, ordinary capillaries, these are also permeable, but permeability is much increased in glomerular capillaries. That helps in the this late time you are entering some students, this is bad. Okay, I mean 42, I understand. Okay, this then slow blood flow through the vasa recta. In kidneys, there are a specialized type of capillary SAD. This person 16, roll 16. Capillaries, these capillaries, there are particular capillaries which are called vasa recta. Vasa means vessel, recta means a straight. These capillaries are straight capillaries. They are this participate in maintaining the high medullary osmolality. Medullary osmolality, the blood flow through these capillaries is extremely slow, and this extreme slow blood flow through the vasa recta is important for maintaining the medullary hyperosmolality, which is basis of countercurrent mechanism. And this countercurrent mechanism is again responsible for producing concentrated urine. Concentrated urine, okay? Next, renal blood flow. Volume blood flowing through both kidneys per minute. This is important to know how much blood passes through the both kidneys per minute. It is almost 1/4 of the cardiac output. If the cardiac output is per minute is 5 liters, you see the renal blood flow is 1215 ml. That means 1.25 liter per minute. And if it is ml, milliliter, that is 1250 ml per minute. Renal plasma flow. Volume of plasma flowing through both kidneys per minute. It is about 650 ml per minute. This is average in adult persons. Okay, adult persons irrespective of sex. Now come to the point GFR. It is the rate of formation of glomerular filtrate. And simplest definition is the rate of formation of glomerular filtrate can be termed as GFR. If we want to elaborate it more, it is the rate of filtration of plasma by the glomeruli of all the functional nephrons of both the kidneys. GFR, average GFR in adult person is 125 ml per minute. If it is to be expressed in hours, then it is 7.5 liter per hour. If it is to be expressed in days, that means 24 hours, 180 liter per days. Its range is range of GFR in adult person is 100 to 140 ml per minute. This is the range. It should be remembered. Average urine flow in an adult person, 1.5 liter per day. So in GFR, you see that from the volume, this 180 liter per day is being filtered per day. Of this, only 1.5 liter is forming urine. Rest that means 178.5 is reabsorbed. Is it clear? Filtration fraction. We will be continuing very few, but this filtration fraction is important. Ratio of GFR to renal plasma flow. Ratio of GFR to renal plasma flow is called filtration fraction. This ranges between 0.16 to 0.20, or it can be on average it is 20%. Filtration fraction 20% means 20% of the renal plasma flow passes through the glomerular capillaries, while 80% passes through of renal plasma flow enters from the efferent arteriole to efferent arteriole. Is it clear? Is it clear? The plasma filtration fraction 20% means renal plasma flow. The 20% of the renal plasma flow enters through the glomerular capillaries, and 80% enters from efferent arteriole to efferent arteriole. They enter into the glomerular capillaries for filtration and reabsorption in the tubules. It is filtered in the glomerular capillaries, then it is subsequently reabsorbed, and there occurs secretion in the renal tubules. Okay, then ultimately it passed into urine. Okay, there are only 2 minutes. Let us see this with these 2 minutes how we can do nephrons. Definition of nephron. Nephrons are the structural and functional unit of kidneys. Nephrons are structural and functional unit of the kidneys. Each kidney approximately has 1 million nephrons. In adult person, each kidney has about 1 million, that means 10 lakh nephrons. Functionally, it is of two types: cortical nephrons, juxtamedullary nephrons. Cortical nephrons, these nephrons are confined to the renal cortex, has short loops of Henle. Juxtamedullary nephrons, these nephrons, their cortex is near the corticomedullary junction. They have long loops of Henle. Long loops of Henle. These juxtamedullary nephrons are involved in formation of concentrated urine. Is it clear? Juxtamedullary nephrons. So cortical nephrons main function is filtration of plasma, and juxtamedullary nephrons formation of filtration as well as formation of concentrated urine. Okay, a nephron consists of two parts: renal corpuscles and renal tubules. Renal corpuscles and renal tubules. Okay, as there is less than 1 minute, renal corpuscle means glomerular capillaries encased in Bowman's capsule. This is called renal corpuscles. Okay, and renal tubules consists of proximal tubule, distal loops of Henle, distal tubule. As there is only less than 1 minute, so and we have no scope to include